This is lesson 9.5, application of quadratic functions. So basically, we've learned all this stuff about quadratic functions. Now we're going to learn why they're useful. So we're going to use an example. You took a photography in class and you want to frame it. The size for your original photograph is 8 by 10. And you want to frame it so that the total space is 168 square inches. How wide do you need to make the border around your picture? Well, here's your picture. I went ahead and used the sea turtle picture because I love turtles. Okay, so we want the total area of the frame to be 168 inches. We want the total area of the whole picture framed. Now we need to figure out the width of the frame, so we're going to call that x. So if we take our picture, we can draw like a little frame around it and call our frame width x. Now I have an 8 by 10 picture, so that's our 8 and 10. And then we add x to the top, x to the bottom, x to the right, and x to the left. That makes the length of the picture in the frame. So the length is x plus 10 plus x, or 2x plus 10. And the width, that's here, I have x plus 8 plus x. So that's 2x plus 8. Now, to solve for x, we need to solve for the area to be 168. So we're going to need to set this up and create a quadratic equation, or a quadratic formula. That's not a formula, it's an equation. The formula is what we use to solve the equation. Okay, so I have 2x plus 10 is my length, 2x plus 8 is my width, and remember area is equal to length times width, and our area is 168. So first I need to FOIL all this out. So 2x times 2x, that's my first, is going to give me 4x squared. Outside gives me 16x. Inside gives me 20x. And last gives me 80. 168. So I get 4x squared plus 36x plus 80 is equal to 168. And I need to subtract 168 from both sides. So I have 4x squared plus 36x plus 80, that minus 88 is equal to 0. So now we've set it equal to 0, and now we can solve this. Okay, so we'll take our 4x squared plus 36x minus 88 equal to 0, and we'll solve it using the quadratic formula. This should again be equation, sorry about that. Remember our quadratic formula, x equals a negative b plus or minus the square root of b squared minus 4ac over 2a. This is a, this is b, this is c. So I have negative 36 plus or minus the square root of 36 squared minus 4 times negative 88 all over 2 times 4. Giving me negative 36 plus or minus the square root of 36 squared, which is 1296, plus 4 times 88, which is 1408, all over 8, giving me negative 36 plus or minus the square root of 1408 plus 1296 is 2704. All over 8. And if I take the square root of 2704, I get negative 36 plus or minus 52 over 8. 52 minus 36 is 16. So I'll have negative 36 plus 52 over 8, or negative 36 minus 52 over 8. Giving me 16 over 8, or negative 88 over 8, giving me 2, or negative 11. But we're talking about a width of a frame. Can our width be negative 11? No, it cannot. So our width of our frame is 2 inches. And that's how we can solve that. I don't know why that is in there. Okay, anyway, quadratic equations can also be used to determine various aspects of projectile motion. Projectile motion is a motion that occurs when an object is thrown or shot outwards and eventually falls to the ground unless acted upon by an outside force. So, for example, if you throw a ball and somebody catches it, or you shoot a cannon and it hits a wall. But if you don't have anything in the way, it will create projectile motion. So we have throwing a ball, firing a cannon, shooting a basket, launching a paper airplane, firing a gun, things like that. The formula for projectile motion always follows the standard form of the quadratic formula, and A will be negative 16. This has to do with gravity. Thank you, Newton. B is going to be the initial velocity of the object, and C is going to be the initial height of the object. Projectile motion gives us a parabola opening downward. This height, this gentleman's height when he threw the ball is C. How fast he threw the ball is B, and then A, of course, is negative 16, and you can see the shape is a parabola. So here's an example problem. Sarah's launching a snowball at a rate of 16 feet per second from a hill that's 32 feet off the ground. We want to know when the snowball will hit the ground. So we have this hill, which is 32 feet. And here's the snowball, and it gets thrown, and then it's going to hit the ground somewhere. We also want to know what is the maximum height that the snowball reaches. So we want to know the time that it hits the ground and the maximum height that it reaches. Okay, the height is going to be our y at our vertex, and it hits the ground is going to be an x, and it's going to be a positive x. Okay, so if we set up our equation, we have negative 16x squared plus 16x, because it's 16 feet per second, plus 32 equals 0. I'm going to plug this into the quadratic formula, and I will have negative b plus or minus b squared minus 4 times a times c all over 2 times a. It's negative. So I have negative 16 plus or minus 16 squared, which is 256, plus 4 times 16 times 32, which is 2048, all over negative 32, which will give me negative 16 plus or minus the square root of 256 plus 2048, which is 2304, over negative 32. The square root of 2304 is 48 over negative 32. So that gives me negative 16 plus 48 divided by negative 32, and negative 16 minus 48 divided by negative 32, which will give me 32 over negative 32, or 64 negative over negative 32, resulting in a negative 1 or a positive 2. Well, our time can't be negative, so our time is 2 seconds. So that's our answer, 2 seconds until it hits the ground. Now, what is the maximum height that the snowball reaches? We need to find the vertex. And if you recall, the vertex, the x value, negative b over 2a. So if I plug in negative b over 2a, I get negative 16 over negative 32, giving me a positive 1/2. That is the x value of my vertex. Now to find the y value, I plug in 1/2. Giving me negative 16 times 1/4. So if I take negative 16 and I divide by 4, I'm going to get negative 4 plus 8 plus 32. 8 came from the 16 times 1/2. So I have 32 plus 8 minus 4, which gives me 36 feet. So the maximum height is 36 feet. And that is how we'd solve that snowball problem. Now, Max is also throwing a snowball, but he's 25 feet above the ground. So his starting height is 25 feet, and it's thrown at 18 feet per second. And we want to determine how long it takes us to reach the ground and its maximum height, just like we did. So this time, let's find maximum height first. We have x equals negative b over 2a. Oh, well, first I have to set up the formula. So my formula is negative 16x squared plus 18x plus 25 equals 0. Again, this is my initial velocity and this is my initial height. So I have negative b over 2 times a. So negative 18 over negative 32. Okay, 18 and 32 both divide by 2. That'll give me 9/16 of a second. That's when it hits its maximum height. So to find the height, I take the y value, and I need to plug in 9/16 squared plus 18 times 9/16 plus 25 equals 0. So I need to square my 9/16, which means I'm squaring my 9 and I'm squaring my 16, which is going to give me 81 over 256. Okay, and then if I multiply that by 16, I'm going to end up with 81/16. So actually, what I'm going to do then is I'm just going to draw an arrow and move that over here. So I'm going to have negative 81/16 plus 18 times 9, which is going to be 162/16 plus 25. I don't know why I put the 0 in there. Okay, 162 minus 81 is 81/16 plus 25. So I want to turn 25 into 16ths, so I'm going to multiply it by 16ths. So I'm going to have 481/16, which if I divide out is 30.0625 feet. That's the maximum height. And now I want to see how long until it hits the ground. So I'm going to solve the quadratic formula. Negative b plus or minus b squared minus 4 times a times c over 2 times a. 18 squared is 324 plus 4 times 16 times 25, which is 1600, divided by negative 32. So that will give me negative 18 plus or minus the square root of 1924 over negative 32, which gives me, not an even number. So we're going to have to reduce this. This is not a perfect square. 1924 will divide by 2. And that gives me 962, which will also divide by 2. Give me 481. 8, 9, and 4 gives me 13, so this is not going to divide by 3. So I'm going to check 7. It does not divide by 7. I'm going to check 11. Nope. Now when I took the square root of 481, sorry, of 1924, I get 43, which means I only have to check prime numbers up till 43. So I check 11, I check 13. That one works. I get 13 and 37. 37 is also prime, so I have negative 18 plus or minus 2 times the square root of 481 over negative 32, and that gives me negative 9 plus or minus the square root of 481 over negative 16. That's because everything divides by 2. Now, what I want to do at this point is I'm going to go ahead, because we're looking for time, this doesn't really help me. This is the simplified version, but we're going to approximate. And I'm going to go ahead and plug in and take the square root of 1924. And I'm going to get 43.86342, and it keeps going. So I'm going to take negative 18 minus 43.86, and the reason I'm using the minus is because I need a negative up top when I divide by my negative, because time has to be positive. So I'm going to take 18 and I'm going to subtract the 43.863. And I'm going to get negative 61.863 over negative 32, and I'm going to divide by 32 to get 1.93 seconds. Again, this is the most accurate answer, but we need to approximate it because we're looking for time. So we're going to get 1.93 seconds. Okay, next we decide to kick the snowball, and he can kick it at 24 feet per second. So we're going to do the same exact thing, except this time he's going to be a little bit faster. He's at the same height. So negative 16x squared plus 24x plus 25 equals 0. All right. Time till it hits the ground. I have negative 24 plus or minus 24 squared minus 4 times negative 16 times 25 all over 2 times negative 16. So I have negative 24 plus or minus the square root of 24 squared, which is 576, plus 1600 all over negative 32, which is negative 24 plus or minus the square root of 2176 over negative 32. Okay, if I take the square root of 2176, I'm going to get a decimal again, but I'm going to go ahead and keep that decimal because, again, we're looking for time. And I'm going to do the subtraction only because I want it to be positive. So negative 24 minus the 46.65 over the negative 32. So I'm going to get negative 70.65 over negative 32. And I'm going to divide by 32, and I get 2.21 seconds. Now we're going to find the maximum height. So I need to find the x value of the vertex. So I have negative b over 2a, giving me negative 24 over negative 32, giving me These both divide by 4. So that would give me negative 6 over negative 8, which both divide by 2. Giving me negative 3 over negative 4, which is a positive 3/4. Then I need to plug that in. So I have negative 16 times 3/4 squared plus 24 times 3/4 plus 25. That's what y will equal. 3/4 squared is going to be 9/16. So that's going to be negative 16 times 9/16 plus 4 goes into 24 6 times. So 6 times 3 is 18 plus 25. 16 goes into 16 once. So that'll be negative 9 plus 18 plus 25, which will be 9 plus 25, which will be 34 feet. So as you can see, when he kicked it, it went further because it traveled for longer, and it got higher because it went 34 feet. Okay, now to solve quadratic literal equations. So Galileo determined that the position of a particle is modeled by a function s is equal to ut plus 0.5 at squared. That should be a squared up here, where u equals the starting velocity, t equals the time, and a equals acceleration, and s is the position of the particle at time t. That's the position. So traffic accident investigators use this formula to determine the speed of a car when the driver hits the brakes. So we want to rearrange the formula to solve for u, which is the initial velocity. So I'm going to take that formula again. I'm going to rewrite it here. And I want it to be equal to u. So first I'm going to write it to where the u is on the side that I want it on. Now I'm going to subtract this 0.5 at squared from both sides. That gets rid of that, and now I've got ut is equal to s minus 0.5 at squared. Now I need to get rid of this t. I want the u by itself, so I need to divide by t. So I'll get u is equal to s minus 0.5 at squared over t. Now if I want to make that a little bit cleaner, I can split it. And I have s over t minus 0.5 at. And the reason that's 0.5 at is because the t and the t squared can cancel each other out. And that's our application of quadratic equations.